a function being positive versus what I'm looking for to be positive when you're increasing are two different things. So when you say it is positive, what are you talking about? No. The function being positive means the function's above the x-axis. That's different than a function that's increasing. Yes? For example, this one is increasing the entire way, but it's not positive the entire way. It's only positive where it's above the x-axis, and it's negative where it's below. So when a function is increasing, that means its blank is positive. No! Slope. It's slope. Increasing means you have a positive slope. That's different than when the function itself is positive, aka above the x-axis. There's a difference. What's that? No, we're not going to use. We're just going to look at it and say this is going uphill, so it's positive. Slope, meaning it's increasing. This is decreasing, and constant means a slope of 0. So we're going to deal with intervals, increasing, decreasing, constant, and then relative max and relative minimums. So something is a relative minimum right here at B, for example, if the points directly to the left and directly to the right both are higher than it. That's what makes it a minimum. And what makes it a maximum is if the points directly to the left and directly to the right are less than it. That's obvious. What's not as obvious is what happens when you have something like this. Is that a relative maximum? No, because the points to the left of it and to the right of it are not lower because you don't have any points to the right of it. So it can't be maximum relative to points on either side if points don't exist on the other side. So be careful of that. But it is an absolute maximum in this case, because an absolute max or an absolute minimum point is the absolute highest point that ever gets reached in a function. And that is definitely the absolute highest it gets. So this is an absolute max, but not a relative max. And sometimes things are a relative max, like right here. That's a relative maximum to the points directly to the left, directly to the right, but it's not an absolute. So it's a relative max, but not an absolute. So you can be one without being the other is what I'm trying to show you here. Or you might be both. So just on a basic parabola, that's the absolute max. That's also a relative max. So you can be both. You can be one but not the other in either order. Any questions on that? I have a debate. You do? Get out. You're kidding. What do you think about what type of a function is that?
Both.
What type of a function is that? When it comes in different pieces? Is that hard for you to see because it's overlapping? When you have two different pieces? Piecewise. That's a piecewise function. So here's something I literally have never thought about until today. And the question is, would this be considered a relative minimum?
Definitely not.
Yeah, which piece?
Definitely.
It's not.
Definitely
okay, let me back up because Brock asked which piece. Pieces aren't relative minimums. Points are.
Right.
So this point right here.
That's a relative minimum.
Is it a relative minimum? Is it a minimum relative to the points directly to its left and the points directly to its right. There are points to the right of it. It's not continuous, so they're not connected, but there are points to the right of it.
So yes, it is.
This is some sicko mode type stuff, right?
Yeah, that's for real.
So I've been teaching all of this forever now. I would say, based on the definition in the PreCalc book,
It's not.
it is a relative minimum.
It's not on today, dude.
But I was a little bit suspicious because it's like definitely a quirky case. I don't know if you'll ever run into this, but I asked Mrs. Hill. Her gut was that it's not because it needs to be continuous and we have that break. So it's not a continuation.
That makes sense to you? Do you agree with that?
Well, that was why I was not sure that I believed the definition in this book.
Okay.
But she said she thought, she wasn't 100% because it is a weird case.
Right.
She thought in the calculus world of AP, they would say, no, it has to be continuous. But I checked my calc textbook. I don't know if there's an actual AP calc textbook, but calc is calc. The calc textbook also would define that as a relative minimum. They don't actually ever show an example like this, but if I check the wording, this matches and satisfies the wording. So I'm still looking for, I'm going to have to Google it precisely. But anyway, I thought of it, I wondered about it, I asked about it, and I still have no answer.
We should call a professor about it.
I could email one of my college professors about it.
Yeah, I'll email
Well, I was,
guess it's interesting.
my previous class was just working on something, and I was like, what am I teaching these guys today? So I just took a quick glance, and I thought, oh,
Wait, so we put this on a test?
I'm not going to put it on a test.
We put it in trick question.
I'm not going to put it on a test because obviously, and this does happen in math where different textbooks define things differently. There's weird and random things here and there where that happens, but it does happen, and there's not
That's why we shouldn't learn.
at all. All right. So anyway, did you have a question, Tommy, or no? All right. So that was just a fun little debate. All right. On this one, state the intervals. Now, intervals, when you're looking at increasing, decreasing, or constant, positive or negative, any of these types of intervals, you do not look at the y numbers, which is tricky to do because you're saying, oh, well, it's starting to increase here to here. And you're looking, it's increasing from 0 to 4 is what a lot of kids say, and that's not right because they're looking at the y-axis, which you just pretty much want to blot that y-axis right out of your head. You got to say from what x-coordinate to what x-coordinate is this increasing. So for increasing, it's from an x-coordinate of 0 to an x-coordinate of 2. Now, interval notation, here's the next question. This does have a definitive answer. Is it actually increasing at the starting point? No, it's not. It actually has a slope of 0 at that kind of relative minimum. So it's not increasing or decreasing. It's kind of in that transition point where it was decreasing and instantaneously right there, it's not doing either of those things, and then it starts increasing again. So that has a parenthesis, and same thing is at 2. That has a parenthesis. I'll give you a quick hint that'll cover all this. You won't have to think about it ever again. Any interval where you're describing increasing, decreasing, or constant, always parentheses. It never will have brackets. Okay? What? That's just a hard and fast rule. Decreasing. So thinking about your x-axis only, it's decreasing from where to where? Negative infinity to 0. Do you buy that? Good. And again, use your union symbol.
Yeah.
2 to, not negative infinity, because we're going to the right. You're looking at the y-axis again. 2 to positive infinity. Good. And there's no interval where it's constant here. Okay, increasing on this one, Laura. 0 to infinity. Good. Faith, what else can you tell me about this one? We just covered this interval. What's happening here? Constant. So that's from where to where? Flip that.
Or negative 30.
Yep. Good. And the last one, Mike, tell me something. Anybody disagree? Good. Maya, tell me something else. So he covered this little stretch here. Anybody disagree? Tommy? Right, it's actually from 1. Good. Usually, not always, but usually where one ends, the other would then begin. Unless it's, well, even if it's flat for a while. Where it stops decreasing and then it's flat for a while, where the one ends, the other one will be, the constant interval would start with that same number. And so we covered that, we covered this. What about this stretch? What's it doing there, Ryan? This one.
It goes, it's decreasing.
From, and what's your interval? And somebody disagrees. Your interval's right, but Tommy, tell him.
Might be increasing.
Yes.
Just looking at these arrows.
I know, and that's confusing because you're looking at it going down, but that's because you're looking at it right to left. When you're talking about slope or increasing, decreasing, anything, you look at it from left to right. So you might as well just cover up those arrows and not let them get in your head. It's definitely going uphill from left to right. So from negative infinity to negative 1. All common mistakes. This stuff isn't like hard, but for whatever reason it can mess with your head a little bit and can get confusing. Alright, so on number 2, we're looking for the numbers, if any. Now here we have to be careful about language. This is saying the numbers at which there's a relative max or a relative min. Sometimes they'll ask you for the value of the relative max or the relative min. So the number at which it's occurring, that's your x-coordinate. That's telling you the location that it's happening at. The value, if they ask for the value of the relative max or the relative min, they're looking for what is that height or, you know, that maximum height or that minimum height. Does that make sense? Small difference, but totally different answer. One is you're looking for the x-coordinate, and the ones you're looking for y. And rarely they'll say at what point does it occur, and then obviously you just give them the full point. So this one asking, find the numbers, if any, at which it has a relative maximum is still, again, looking at the x-coordinate. Faith? X equals 2 is correct for the relative max. Is there a relative minimum? Alyssa, what do you think? I'm sorry, I was not listening to you. I'm looking at this question and wondering why it's there.
Yeah, what's next to that?
I think it's just a repetition, right?
I'm so confused as to what max.
Are you going to ask her a question in like Spanish?
Why?
What is the maximum?
That's Latin, I think, isn't it? Is it? Minimums? You wouldn't just throw an... Oh, really? Now I gotta Google it. This is how people become good at Jeopardy, right? They just Google anything they're curious about. I got some news for you when we're done with this. I'm sorry. Poor Alyssa. Going back to that question, does this have a relative maximum?
We already went over that.
No, she didn't answer that. Oh shoot, I wrote it.
Minimum.
So no, we didn't do it wrong.
It's supposed to be minimum.
Oh, forget everything I said.
You're playing mind games.
I'm not. I thought this was just a verbatim copy. I thought this was relative max, relative min, and I was reading too fast. So, at which value is the relative maximum, and what are these relative maximum? Give me the y-coordinate of that 2.4.
What is going on here?
So, below that, it's minimum. Got it. So, Alyssa, this was the question I meant to ask you. Does this have a relative minimum? Yes or no?
Yes.
Alyssa. Yeah, I don't blame you. The question is, Alyssa, on this graph, at which x value is the relative minimum occurring? Alyssa. Zero. It's occurring right here, which is at an x coordinate of 0. Good. And what is that relative minimum value, Brock? What's the y coordinate? What is the relative minimum value? 0. Good. All right. This next one's going to be a little bit trickier. On this graph, do you see a relative maximum? Do you see a point that is higher than the points both directly to the left and to the right of it?
No.
Correct. So there does not exist. DNE. That's good too. How about relative minimum? Do you see a point that's lower than the points directly to the left and directly to the right? Which one are you maybeing? Okay, but 0, 0 is not actually a point on this graph because it's an open circle. So that's the reason we would say no to that one. And then maybe your other option would be this one, but this is not lower than the ones to the left or to the right. So this also does not exist. And relative maximum. Do you see a relative maximum on this alley? I do. At approximately where? -1 is the x location, so that's the number at which. And the y coordinate on this one, we just kind of have to estimate. Well, look at the scale. So I would say maybe like 2-ish. I'd have to, on a test, you'd get something more precise. 2-ish, sure.
This is the longest.
On a test, it will be definitive.
Every day I look at the clock and it's the same time.
Maybe I should cover the clock up.
No, please.
Madeline, do you see a relative minimum on this? Well, yes or no, do you see a relative minimum? Here's a loose definition of a relative minimum or relative max. It's not going to apply to this weird example I gave you, but pretty much the majority of relative maxes or relative mins are going to look like the tops of a peak or the bottom of a valley. Yes. Right. Like almost like a little section that looks like the top of a parabola or the bottom of a parabola. So, do you see the bottom of a valley? You should. Do you see it now, Madeline? Where is it? 1, good. And again, we'll approximate -2 for the value. So the only type of question that, again, I obviously gave you like a really weird case right there. That's not common. But there is one type that is not on here that's worth talking about, and that's something like this. So let's pretend that's at -3, and that's at
feel like you're tricking me every time you ask me a question.
No. Wait.
I'm trying to think that you're doing
No.
a great job.
No.
He's saying yes, so if you see
If he's saying yes, I'm saying yes.
an absolute minimum, where is it?
You're making it up.
He doesn't know yet. He just knows it's
Yeah,
there.
I know. There isn't.
He wants to say it's at 6, -5, but your hesitation is, it's not a point. And he's with conviction telling you there is no absolute minimum. And why are you saying that with
Because
conviction?
that's not, and the -5 point is not lower than the values to it.
There's no right side. That's why. There's no right side.
Here's the rule. If you can't quantify it, then it's not an absolute minimum.
So there's nothing there.
Right. There is no absolute minimum.
Let's go.
We know it. Derek, Tommy, you need to sit down again.
Yeah. Group season.
You know it's not actually reaching -5, so you're tempted to be like -4.9. But again, because of that concept of infinity, you can always get closer to -5. You could say -4.999, and then the next person could say -4.99999, and you can get infinitely close to it, so you can't quantify the lowest value it gets to. So therefore, it would not have an absolute minimum. Nor does it have a relative unless this one were to spin around, which it's not. Okay? So that's kind of something, if it's an open circle and that's the lowest quote unquote point, it's not really a lowest point because that's not a point on the graph. Okay. I just got one more problem for you, Rock.
What do you know? Not from you.
I'm just kidding.
Yo, he's $20 for the truck party.
No. I already had a chocolate bar.
Dude, so did JR.
Yeah, so mine is for you.
I need some Chris Bryce though, dude. Are you serious? So did JR, that guy. Dude.
Junk toys. Now I want one.
He's probably down. He's probably down.
That's what you read.
For sure, he's probably down tomorrow.
I have no idea what you just said.
Will you stop me $1 until tomorrow?
I don't have a dollar.
Rough day, man.
Maya. I know you got $1. I know you want me to get a chocolate bar.
All right, you're only doing 3s, 9s, and 7s. So I'm making it up to you instead of
3 9s and 7s. What do you mean?
No, I looked.
Oh, it's all grass.
So I picked 2 problems from this section. That's 3s and 9s.
Stop me down. I'm gonna run in my car out and get these things out of my car. Yeah.
Oh wait, no, hold on. Don't write that. I'm just gonna tell you which ones to do. Did I give your row a thing already?
Yeah, he already gave me.
Well, yeah, you did.
I still let down.
God, no.
I didn't have.
Very good. Dude! Dude!
Alright, here's what you're gonna do. 1s and 3s. 1, 3. Okay, I take it back. 1, 3, and 9.
How about just like one?
Why is this period the longest period of the day?
Because you don't like math.
I like math.
So there's 5 questions, I think, right? Am I missing that? Yeah.
Well, I like math when I know how to do it.
So fake.
Oh yeah. Oh yeah. 6.
Yeah, well, there's no spoiler amount, right?
Of course, it's
Hey guys, on these last 2, these are functions, and they're just pulling the screenshot from what would be shown on a calculator. Because they are functions, you need to assume there are arrows at the ends of them.